lesson is calculating and comparing square roots, and it's lesson 13 in your book. A perfect square is a number that is the square of an integer. So if we can take an integer and multiply it by itself, the solution is called a perfect square. For example, if we multiply 2 times 2, we get 4. So 4 is the perfect square. If we multiply negative 7 times negative 7, we get positive 49. So 49 is also a perfect square. Square roots have these things called radicals. That's the square root symbol that we're used to seeing. It's like a division symbol, but it's got an extra little check mark at the front. This is called a radical. The number or variable or value underneath the radical is called the radicand. This we would read as the square root of x. This one we'd read as the square root of 50. And this one would be read as 2 times the square root of 7. So here's something cool to remember. A square number, a perfect square, can only end in 0, 1, 4, 5, 6, and 9. So when you're evaluating whether or not a number is a perfect square, a good thing to look at is the last number. Because if it's not one of these, it's not a perfect square. However, not all numbers ending in these numbers are perfect squares. 16 is a perfect square because if we multiply 4 by 4, we get 16. Likewise, the square root of 16 is 4. 16 ends in a 6, so it's a good candidate for a perfect square. However, if we go to the next number that ends in a 6, 26, it's not a perfect square because there's no integer that we can multiply by itself to get 26. Here's an example problem. You definitely need to write this one down in your notes. The question is the radicand in the square root of 50 a perfect square? And explain. First, we need to know what's the radicand in the square root of 50. The radicand means the value underneath the radical, which here is 50. Now, is 50 a perfect square? Well, it ends in 0, so it's a good candidate. We know it has to end in 0, 4, 0, 1, 4, 5, 6, or 9 to be a perfect square. Now, is there a number that we can multiply by itself to get 50? Well, we already talked about if we multiply 7 times 7, we get 49. So that's pretty close. Now let's try 8 times 8. 8 times 8 gets us 64. Since there's no integers in between 7 and 8 that would get us 50 when we multiply by itself, the radicand 50 is not a perfect square. So here we would say no. And then we have to explain our answer. So we say no because seven squared equals 49, and 8 squared equals 64, and there are no integers between 7 and 8. We can also say no because no integer can be multiplied by itself to equal 50. So there are two possible explanations there. Here's another example. Again, this one needs to be in your notes. It says, is the radicand in the square root of 64 a perfect square? And explain. So we look at the radicand of the square root of 64. Here our radicand is 64. Notice that it ends in one of those magic numbers that a perfect square can end in. So it's a good candidate. Now, is there a number that we can multiply by itself and get 64? Well, we know, as we just talked about in the last slide, that 8 times 8 equals 64, or 8 squared equals 64. So this one is a perfect square. So we're going to say yes, and we have to explain our answer. So we say yes, because when 8 is multiplied by itself, the answer is 64. Now here's another example. We want to estimate the value of the square root of 50 to the nearest integer and explain our reasoning. So first we have to look at the perfect squares around 50. We've already decided that 50 is not a perfect square, but we want to look at the perfect squares around 50. So if we multiply 7 times 7, we get 49. Now that's below 50. If we multiply 8 times 8, we get 64. Which is above 50. We know that the square root of 50 is going to be somewhere between 7 and 8, and we want to estimate it to the nearest integer. So, we either need to round the square root of 50 to 7, or we need to round the square root of 50 to 8. To do that, we look at their perfect squares. Which perfect square is 50 closer to? Well, 50 is only 1 away from 49, but it's 14 away from 64. So, the value of the square root of 50, estimated to the nearest integer, is going to be 7. And that's because is closer to 7 squared than to 8 squared. So when you're estimating the value of the square root, you look at the square roots with perfect squares around the radicand, closest to the radicand, and decide which one is actually closer. For our final example, we did ballroom dancing. The area of a dance floor that is in the shape of a square is 289 square feet. What is the side length of the dance floor? Explain. Again, this is an example and you need to write it in your notes. Now they tell us that we have a square dance floor. I'm going to try to draw a square. Please bear with me. I'm not so great at drawing. That means that when we multiply the area, means we have to multiply one side by another. So when we multiply x times x, we get 289 feet. So x times x, or x squared, equals 289 feet. Now to solve this, we're looking for what is the square root of x squared, or what is the square root of 289. The side length of our dance floor is going to be the square root of 289. Now, is 289 a perfect square? Well, it ends in a 9, so it's a good candidate. So let's think about some square numbers near 289. We know 13 squared is 169. We know that 14 squared is 196, so still not close enough. Let's try 16 squared. That's 256, getting closer. Now if we square 17, we get 289. So what number do we need to square to get 289? 17. So this ballroom dance floor is 17 feet by 17 feet. Because the square root of 289 is 17.